Last session, we looked into point and line. This week, we will look into understanding planes and volume. There are two ways a plane is produced. First, a line is extended in a direction other than its intrinsic direction and becomes a plane. Conceptually, a plane has length and width, but no depth. Shape is the primary identifying characteristic of a plane. It is determined by the contour of the line forming the edges of a plane. Another way to create a plane is through lines. Two parallel lines have the ability to visually describe a plane. A transparent spatial membrane can be stretched between them to acknowledge their visual relationship. The closer these lines are to each other, the stronger will be the sense of plane they convey. A row of columns supporting an entablature, called a colonnade, is often used to define the public face or facade of a building, especially one that fronts on a major civic space. A colonnaded facade can be penetrated easily for entry, offers a degree of shelter from the elements, and forms a semi-transparent screen that unifies individual building forms behind it. In addition to the structural role columns play in supporting an overhead floor or roof plane, they can articulate the penetrable boundaries of spatial zones which mesh easily with adjacent spaces. These two examples illustrate how columns can define the edges of an exterior space defined within the mass of a building, as well as articulate the edges of a building mass in space. The linear members of trellises and pergolas can provide a moderate degree of definition and enclosure for outdoor spaces while allowing filtered sunlight and breezes to penetrate. In the composition of a visual construction, a plane serves to define the limits or boundaries of a volume. If architecture as a visual art deals specifically with the formation of three-dimensional volumes of mass and space, then the plane should be regarded as a key element in the vocabulary of architectural design. Vertical and horizontal linear elements together can define a volume of space. Note that the form of the volume is determined solely by the configuration of the linear elements. In architecture, we manipulate three generic types of planes: the overhead plane, the wall plane, and the base plane. The overhead plane can be either the roof plane that spans and shelters the interior spaces of a building from the climatic elements, or the ceiling plane that forms the upper enclosing surface of a room. The wall plane, because of its vertical orientation, is active in our normal field of vision and vital to the shaping and enclosure of architectural space. The base plane, on the other hand, can be either the ground plane that serves as the physical foundation and visual base for the building form, or the floor plane that forms the lower enclosing surface of a room upon which we walk. Conceptually, a volume has three dimensions: length, width, and depth. All volumes can be analyzed and understood to consist of points or vertices where several planes come together, lines or edges where two planes meet, or planes or surfaces that define the limits or boundaries of a volume. In architecture, a volume can be seen to be either a portion of space contained and defined by wall, floor, and ceiling or roof planes, or a quantity of space displaced by the mass of a building. Building forms that stand as objects in the landscape can be read as occupying volumes in space. Building forms that serve as containers can be read as masses that define volumes of space, and a series of buildings can enclose an urban square. Volume can also be carved out, as seen here in the Buddhist Chatya Hall, where the volume of space is carved out of the mass of solid rock. In the following section, we will look at horizontal and vertical elements of form and present examples of how various configurations of these formal elements generate and define specific types of space and play with planes and volumes. A base plane is a horizontal plane laying as a figure on a contrasting background and defines a simple field of space. This field can be visually reinforced in the following ways. Through an elevated base plane, where a horizontal plane is elevated above the ground and establishes vertical surfaces along its edges that reinforce the visual separation between its field and the surrounding ground. Or through a depressed base plane, which is a horizontal plane depressed into the ground plane and utilizes the vertical surfaces of the lowered area to define a volume of space. And finally, the overhead plane, which is a horizontal plane located overhead that defines a volume of space between itself and the ground plane. For a horizontal plane to be seen as a figure, there must be a perceptible change in color, tone, or texture between its surface and that of the surrounding area. Although there is a continuous flow of space across it, the field nevertheless generates a spatial zone or realm within its boundaries. The surface articulation of the ground or floor plane is often used in architecture to define a zone of space within a larger context. Elevating a portion of the base plane creates a specific domain within a larger spatial context. The changes in levels can define boundaries and interrupt the flow of space across its surface. The degree to which spatial and visual continuity is maintained between an elevated space and its surroundings depends on the scale of the level change. For example, when the base is elevated slightly, at a height where someone can easily sit on the elevated base plane, the edge of the field is well defined, as you can see across to the other side or see anyone walking on the platform. This ensures that the visual and spatial continuity is maintained, and people have a physical access to the raised base plane, as in they can sit or step on it easily. However, when the base plane is elevated high and at the eye level, then you still have visual continuity, as you can see what is above that level. However, spatial continuity is interrupted because you can't easily access the raised platform. And if you do need physical access, then you would need to install stairs to reach the elevated base plane. And finally, when the base plane is elevated above the height of a human, the visual and spatial continuity is interrupted because you can't see or access the raised platform. This break in spatial continuity also causes the elevated plane to be isolated from the ground or floor plane. In most cases, you can accommodate another space below the raised plane. Elevating a portion of the ground plane establishes a platform or podium that structurally and visually supports the form and mass of a building. Sometimes buildings are placed on a naturally raised base plane to showcase the importance of the function of the building, such as the Acropolis in Athens that houses temples. You can also see elevated base planes in Malay traditional architecture, where houses are raised to avoid floods and animals. An elevated plane can also define a transitional space between the interior of a building and the outdoor environment. Combined with a roof plane, it develops into the semi-private realm of a porch or veranda, as seen in the Farnsworth house. The house was constructed with an elevated floor plane and an overhead roof plane that defines a volume space that hovers delicately above the surface of its site. Religious buildings can also have raised platforms to help worshippers to view religious leaders and focus on being connected through prayer. Lowering a portion of the base plane isolates a field of space from a larger context. A contrast in form, geometry, or orientation can also visually reinforce the identity and independence of the sunken field from its larger spatial context. The degree of spatial continuity between a depressed field and the raised area surrounding it depends on the scale of the level change. The depressed field can be an interruption of the ground or floor plane and remain an integral part of the surrounding space. Increasing the depth of the depressed field weakens its visual relationship with the surrounding space and strengthens its definition as a distinct volume of space. Once the original base plane is above our eye level, the depressed field becomes a separate and distinct room in itself. Creating a stepped, terraced, or ramped transition from one level to the next helps promote continuity between a sunken space and the area that rises around it. Whereas the act of stepping up to an elevated space might express the extroverted nature or significance of the space, the lowering of a space below its surroundings might allude to its introverted nature or to its sheltering and protective qualities. Depressed areas in the topography of a site can serve as stages for outdoor arenas and amphitheaters. The natural change in level benefits both the sightlines and the acoustical quality of these spaces. The Rockefeller Center in New York has a lower plaza that works as an outdoor cafe in the summer and an ice skating rink in the winter. It can be viewed from the upper plaza while shops open onto it at the lower level. The ground plane can be lowered to define sheltered outdoor spaces for underground buildings. A sunken courtyard, while protected from the surface level wind and noise by the mass surrounding it, remains a source of air, light, and views for the underground spaces opening onto it. An area within a large room can be sunken to reduce the scale of the room and define a more intimate space within it. Similar to the manner in which a shade tree offers a sense of enclosure beneath its umbrella structure, an overhead plane defines a field space between itself and the ground plane. Since the edges of the overhead plane establishes the boundaries of this field, its shape, size, and height above the ground plane determines the formal qualities of the space. If vertical linear elements such as columns or posts are used to support the overhead plane, They will aid in visually establishing the limits of the defined space without disrupting the flow of space through the field. Similarly, if the edges of the overhead plane are turned downward, or if the base plane beneath it is articulated by change in level, the boundaries of the defined volume of the space can be visually reinforced. The major overhead element of a building is its roof plane. It not only shelters the interior spaces of a building from rain or sun and snow, but also has a major impact on the overall building form and the shaping of its spaces. The form of the roof plane, in turn, is determined by the material, geometry, and proportions of its structural system and the manner in which it transfers its load across space to its supports. The roof plane can be a major space-defining element of a building and visually organize a series of forms and spaces beneath its sheltering canopy, as seen in the pavilion by Le Corbusier. The ceiling plane, on the other hand, can reflect the form of the structural system supporting the overhead floor or roof plane. Since it does not need to worry about weathering forces or loads, the ceiling plane can also be detached from the floor or roof plane and become a visually active element in space. The form, color, texture, and pattern of the ceiling plane can be manipulated as well to improve the quality of light or sound within a space or give it a directional quality or orientation. As in the case of the base plane, the ceiling plane can be manipulated to define and articulate zones of spaces within a room. It can be lowered or elevated to alter the scale of a space, define a path of movement through it, or allow natural light to enter it from above. Vertical forms have a greater presence in our visual field than horizontal planes, and are therefore more instrumental in defining a discrete volume of space and providing a sense of enclosure and privacy for those within it. In addition, they serve to separate one space from another and establish a common boundary between the interior and exterior environment. Vertical linear elements define the perpendicular edges of a volume of space, while the single vertical plane articulates the space on which it fronts, and the L-shaped plane configuration of vertical planes generates a field of space from its corner outward along a diagonal axis. On the other hand, two parallel vertical planes define a volume of space between them that is oriented axially towards both open ends of the configuration, while the U-shaped plane configuration defines a volume of space that is oriented primarily towards the open end of the configuration, and the four-plane, which creates a closure, establishes the boundaries of an introverted space and influence the field of space around the enclosure. As we already know, two columns can establish a transparent spatial membrane by the visual tension between their shafts. Three or more columns can also be arranged to define the corner of a volume of space. This space does not require a large spatial context, but its definition relates freely to it. The edges of the volume of space can be visually reinforced by articulating its base plane and establishing its upper limits with beams spanning across the columns or with an overhead plane. A repetitive series of column elements along its perimeter would further strengthen the definition of the volume. A regularly spaced series of columns defines an edge of a spatial volume, while permitting visual and spatial continuity to exist between the space and its surroundings. A row of columns can also engage a wall and become a pilastrate that supports the wall, articulates its surface, and tempers the scale and rhythm. A grid of columns within a large room or hall not only serves to support the floor or roof plane above, but the orderly rows of columns also punctuate the spatial volume, mark off modular zones within the spatial field, and establish a measurable rhythm and scale that makes the spatial dimensions comprehensible. Clearly seen in plans, a column grid establishes a fixed, neutral field of space which interior spaces are freely formed and distributed, as well as the columns and posts constructions fits the structure and space closely. The field of space on which a single vertical plane fronts is not well defined. The plane by itself can establish only a single edge of the field. To define a three-dimensional volume of space, the plane must interact with other elements of form. The height of a vertical plane relative to our body height and eye level is a critical factor that affects the ability of the plane to visually describe space. When 2 feet high, a plane defines the edge of a spatial field but provides little or no sense of enclosure. When waist high, it begins to provide a sense of enclosure while allowing for visual continuity with the adjoining space. When it approaches our eye level in height, it begins to separate one space from another. Above our height, a plane interrupts the visual and spatial continuity between two fields and provides a strong sense of enclosure. When related to a defined volume of space, a vertical plane can be the primary face of the space and give it a specific orientation. It can front the space and define a plane of entry into it. It can also be a freestanding element within a space and divide the volume into two separate but related areas. The Barcelona Pavilion has a few single vertical planes that mark significant planes to form circulation and perspective. An L-shaped configuration of vertical planes defines a field of space diagonally from its corner outward. While this field is strongly defined and enclosed at the corner of the configuration, it dissipates rapidly as it moves away from the corner. The introvert field at the interior corner becomes extroverted along its outer edges. While two edges of the field are clearly defined by the two planes of the configuration, its other edges remain ambiguous unless further articulated by additional vertical elements, manipulations of the base plane, or an overhead plane. If a void is introduced to one side of the corner of the configuration, the definition of the field will be weakened. The two planes will be isolated from each other, and one will appear to slide by and visually dominate the other. If neither plane extends to the corner, the field will become more dynamic and organize itself along the diagonal of the configuration. The L-shaped configuration of planes are stable and self-supporting and can stand alone in space. Because they are open-ended, they are flexible space-defining elements. They can be used in combination with one another or with other elements of form to define a rich variety of spaces. A good example of an L-shaped configuration would be the Kingo housing estate in Denmark. It is designed to enclose an outdoor living space. Typically, one wing contains the communal living spaces, while the other contains private spaces. The advantage of this type of layout is its provision of a private courtyard, sheltered by the building form and to which interior spaces are directly related. In a building, L-shaped walls can create privacy and manipulate circulation to open spaces as the visitor walks into the room. A pair of parallel vertical planes defines a field of space between them. The open ends of the field established by the vertical edges of the planes gives the space a strong directional quality. Its primary orientation is along the axis, about which the planes are symmetrical. Since the parallel planes do not meet to form corners and fully enclose the field, the space is extroverted in nature. The definition of the spatial field along the open ends of the configuration can be visually reinforced by manipulating the base plane or adding overhead elements to the composition. The spatial field can be expanded by extending the base plane beyond the open ends of the configuration. This expanded field can, in turn, be terminated by a vertical plane whose width and height is equal to that of the field. If one of the parallel planes is differentiated from the other by a change in form, color, or texture, a secondary axis perpendicular to the flow of the space will be established within the field. Openings in one or both of the planes can also introduce secondary axes to the field and modulate the directional quality of the space. Sets of parallel vertical planes can be transformed into a wide variety of configurations. Their spatial fields can be related to one another, either through the open ends of their configurations or through openings in the planes themselves. The directional quality and flow of the space, defined by parallel planes, are naturally manifested in spaces used for circulation and movement. These linear spaces can be defined by the facades of the buildings fronting them, as well as by the more permeable planes established by columns. The flow of the spaces defined by parallel planes corresponds naturally to the paths of movement within a building, along its corridors, halls, and galleries. The parallel planes that define a circulation space can be solid and opaque to provide privacy for the spaces along the circulation path. The planes can also be established by a row of columns so that the circulation path opens on one or both of its sides and becomes part of the spaces it passes through. The parallel vertical planes of a bearing wall structural system can be the generating force behind the form and the organization of a building. Their repetitive pattern can be modified by varying their lengths or by introducing voids within the planes to accommodate the dimensional requirements of larger spaces. These voids can also define circulation paths and establish visual relationships perpendicular to the wall planes. The slots of space defined by parallel wall planes can also be modulated by altering the space and configuration of the planes. Parallel bearing walls are often used in multi-family housing developments. They not only provide structural support for the floors and roofs for each housing units, but also serve to isolate the units from one another, curb the passage of sound, and check the spread of fire. The pattern of parallel bearing walls is particularly appropriate for terrace houses in Malaysia. A U-shaped configuration of vertical planes defines a field of space that has an inward focus as well as an outward orientation. At the closed end of the configuration, the field is well defined. Towards the open end of the configuration, the field becomes extroverted in nature. The open end is the primary aspect of the configuration by virtue of its uniqueness relative to the other three planes. It allows the field to have visual and spatial continuity with the adjoining space. The extension of the spatial field into the adjoining space can be visually reinforced by continuing the base plane beyond the open end of the configuration. If the plane of the opening is further defined with columns or overhead elements, the definition of the original field will be reinforced and continuity with the adjoining space will be interrupted. If the configuration of planes in rectangular and oblong in form, the open end can be along its narrow or wide side. In either case, the open end will remain the primary face of the spatial field, and the plane opposite the open end will be the principal element among the three planes of the configuration. If openings are introduced at the corners of the configuration, secondary zones will be created within a multi-directional and dynamic field. U-shaped enclosures of interior space have a specific orientation towards their open ends. These U-shaped enclosures can group themselves around a central space to form an introverted organization. The Hotel for Students by L02 demonstrates the use of U-shaped enclosures to define the basic unit of space in double-loaded schemes for dormitories, apartments, and hotels. These units are extroverted, meaning they turn their back on the corridor and orient themselves to the exterior environment. When you turn the U-shape to view the exterior, it opens up to the environment, allowing for maximum view. Four vertical planes encompassing a field of space is probably the most typical and certainly the strongest type of spatial definition of architecture. Since the field is completely enclosed, its space is naturally introverted. To achieve visual dominance within a space or become its primary face, one of the enclosing planes can be differentiated from the other by size, form, surface, articulation, or by the nature of the openings within it. Historically, four planes have often been used to define a visual and spatial field for a sacred or significant building that stands as an object within the enclosure. The enclosing planes may be ramparts, walls, or fences that isolate the field and exclude surrounding elements from the precinct. In an urban context, a defined field of space can organize a series of buildings along its perimeter. The enclosure may consist of arcades or gallery spaces that promote the inclusion of surrounding buildings into their domain and activate the space they define. Enclosures can also be created through courtyards or atriums in a building. This draws the attention of a person to this paused space that is surrounded by rooms and other functional spaces. In conclusion, a space is defined by several elements, and understanding the primary elements of architecture helps us understand that every single decision in a building is well considered and defined by the intention. As we have seen, points lead to lines. Lines lead to planes, planes lead to volume, and volume leads to space that you and I experience.